Given the vector equation r is equal to cos t cos 2t, where t is between 0 and pi by 2, find the Cartesian equation stating the domain and range. Before we go on to that part, think about the restrictions placed on our Cartesian equation by the vector we're given initially. We know that the cosine of t is strictly between -1 and 1. And that means that the x values have to be between -1 and 1, and the y values also need to be between -1 and 1. But there's more restriction here than that, in that t has to be between 0 and pi by 2. So let's just consider, here's pi by 2, here's 0, and if we think first of all about cos t, cos of 0 is 0, cos of pi by 2 is 1. So we can see from this that our x has to be strictly between 0 and 1. It's the output values, the y values here, that are going to give us that x, because we're looking at values of cos t. What about cos 2t? Well, that's going to be 0 at pi by 4. That one's going to come down and go over to -1 down here. So our y values then are going to be between -1 and 1. So let's bear that in mind when we get our Cartesian equation. So the parametric equations here are that x is equal to cos t and y is equal to cos 2t. But we can write that as 2 cos squared t take away 1 using an identity. And that means, since x is cos t, that we get 2x squared take away 1. So now we want to sketch the path of the particle below. Well, actually we need to state the domain and range here. So we've already worked out that x has to be between 0 and 1. Of course, x can be a real value in that range, and y is going to be between -1 and 1. So if we now sketch 2x squared take away 1, making sure we're in the correct domain, when x is 0, it's going to be -1. When x is 1, it's going to be 1. 2 times 1 squared take away 1. And we know what a quadratic looks like, so it's going to go something like that. Now, think about t being equal to 0. Coming back up here, cos of 0 is 0, cos of 0 is 1, cos of 0 is 1. So the start point would be here. So that is the start, and then it would head in this direction. When we get to pi by 2, the x's would be 0, as shown on this graph just here, and the y would be -1. So this is the end point of the motion.